If you folks remember, I was here last year. I was talking about a project called Mantl. Just a little bit about myself and my company. We started the company in 2014. We're located in St. Louis, USA, which is kind of in the middle of the United States. And basically, our entire company is about infrastructure automation. We write software around cloud containers and helping companies really accelerate the development process. So we usually don't talk to IT people a lot. We usually talk to developers and managers of analytics, teams that just want to move a lot faster with what they're doing. So today we're going to talk about a project that we've been writing software for about 6 months, but before that we've been discussing it for about a year. And it's a tool called Converge, which is in a lot of ways the rethinking that we've been doing about how we configure and manage systems. So probably the first question people ask is, why would we build another configuration management tool? Because there's already a lot of tools in the space. One of the first ones was CF Engine. If you remember last year, they had Mark keynoting here, so that was pretty incredible. I thought that was a great find that you guys did. Then there's tools like Chef, Puppet, Salt, and Ansible. Ansible is bought by Red Hat, so there's multiple competitors in the space. So people often ask, like, why build another tool? Well, we had a lot of reasons. And first I want to talk about some trends and why. Like, the first thing that we're seeing is that with the rise of things like Kubernetes and Docker, it's really kind of changing the way people think about infrastructure. And before, when people were like really doing complex configurations on servers, now what they do is like hit a Kubernetes API and have Kubernetes take care of doing things like stateful sets and replicating databases and running applications and doing things like failover, right? So a lot of the tasks that used to be used by configuration management are now moving up the stack to these scheduler platforms, right? So that's leaving a smaller gap there of what happens on systems. The next thing is, and I'll talk about this in a second, but what's happening a lot we're seeing in DevOps right now, and this is, we both, as part of Mantl, we had a lot of automated testing, right? So we would spin up Mantl on 6 or 7 different cloud platforms for every commit, right? So what we're seeing here is that there's a trend, again, that increasingly continuous integration, continuous delivery is happening on the infrastructure side, right? So it's not like you fire it once and you let it go. You're basically creating images, whether they're Docker images, whether they're Amazon AMIs. So we're seeing a lot more CI going into that. And finally, what we're starting to see on the low end side is that what used to be a lot of embedded devices are starting to move to like Raspberry class devices, which run a full Linux OS, right? So this is what we're starting to see. So the question is, can we bring those really rich developer and server management tools down to IoT platforms like the Raspberry Pi, right? So we're thinking, what's configuration management going to look like in the next few years? So really, the origins of Converge were based on what I talked about last year, Mantl. So Mantl is this platform that, if you didn't see my talk last year, it runs Kubernetes, Mesos across 6 or 7 different cloud providers. It automates the whole stack from security to load balance and ingress. And Mantl is basically built on Terraform for the multi-cloud and Ansible, and that bridge, we wrote some bridges between Ansible and Terraform, but as we delivered Mantl, we were increasingly frustrated with Ansible. Even though we think it's incredibly powerful, we were finding that for shipping software on top of it, it didn't work really well. The model of using a huge Git repo for everything was difficult to get other people to contribute code back. And actually, when we go talk to companies, we see this. They have, they say they run Ansible, but every group has their own fork of the Ansible. So there's not a lot of commonality. And that was like a lot of our frustrations. And really, and then we started thinking about, like, as we built Mantl out, like, what would our ideal? So as I said, we took like a year thinking about what would our ideal tool look like. So one of our goals was we want to deploy an entire cluster, like a Kubernetes cluster with one command, right? So that allows us to do automatic testing and validation, because one part of Mantl was that we do a validation step, we hit the console API after the fact and confirm that the systems were configured. We really got tired of compiling things with configuration management tools. We wanted a single binary that was pretty small and contained everything. And finally, we got a little frustrated when we would run, Mantl had over 250 Ansible tasks, and if we deployed that to like 15 servers and one of the tasks failed, it would just, that server was done. So we're like, we needed a better way of predicting what was going to happen on the server and communicating, something better than SSH. So those are kind of the goals. So that's Converge. So at its very basic, Converge is like Chef or Puppet or Ansible like that. It does the basic things on a Linux system, right? So it installs packages, it manages user and groups. It launches Docker containers if you want. We just added in 0.6 systemd support, so there's really cool systemd support, and you can actually do introspection on systemd, so you can say, hey, is this module running, is it loaded, or anything like that. You could actually create a systemd subsystem, and it also does logical volumes, which is something we needed a lot, because an often pattern that we do when we're deploying Docker is that we actually attach an external volume to a VM, so that the Docker volumes don't corrupt the root volume, because Docker has a tendency to fill up everything. So one thing we do here, since we have Terraform integration, is we pass the Terraform disk as a variable into Converge, right? Because we have a built-in Terraform module so that we say this is the disk, and then we can pass it on to Converge, and Converge can configure the entire LVM process for us. Again, so our focus here is deploying things like Kubernetes and Docker Swarm. And then finally, it does things like files and directories. So that's basically it. So you give it a set of commands, and it'll configure your system for you. And it's easy to use. Converge is just a single binary. It's cross-compiled for Mac, Linux, and Linux ARM. So it runs exactly the same on your Mac as it does on your Raspberry Pi. And a really important part of this, since it took me like 2 weeks to learn how to even do one thing in Chef, is that we really want to have it be very simple, right? So it's just a single file. If you've ever used Terraform before, it's very similar. You just give it a file, right? And you just run the binary on it. That's it. That's very basic, and we just want to have, that's the core experience. And as we add things like networking and other things, we're always going to have that core experience where it's just a single binary, a single file, it's easy to run. And as you can see, if you've ever used, how many folks here have used Terraform before? Wow, okay. So I shouldn't assume, Terraform is a tool which I'll actually demo here if the network is working. It allows you to describe an entire cloud infrastructure and execute it in the graph-based mode. It's really cool, but there's two things you do. You do a plan where you say, where the system actually, since we have a graph-based tool, it actually, Converge will calculate all the differences in one shot and tell you what it is. So when you do a plan, it doesn't do anything. It just looks at your system versus what you described, and it comes back with all the things it would do. And then after that, you can say, hey, I want to apply, it actually does the work, and then you can override parameters on the command line. So it's very simple. Again, it's very Unixy. And we use HCL, which is HashiCorp Configuration Language, which is a superset of JSON. And it's designed to be fairly simple, so there's a couple things I want to show here about the syntax. This is for actually launching a Docker container on the system. So the first thing up there you see is we set a parameter. Like you see in the last example, I overrid it on the command line, but here you can set a default, right? So we just say here is tag. And then when you look here at the Docker image, right, so that's one of our resources. So this will actually pull down a Docker image. And you can see here, we're just referring to the parameters right before it. And then finally, we're going to launch that Docker container. Now, this is one of the really cool features about, we'll talk about the graph-based engine here. We actually look for the tag for this other image here, so we're creating a dependency automatically, right? So we talked about, and how many folks here saw the management talk, MGMT talk before? The guy who's given it, and I think something that's really cool here, and I think, is this idea of applying graphs in infrastructure. Like you see it in Puppet, you see it in Salt, you see it in Terraform, like really representing infrastructure as a graph. So here we actually create an, so we can actually set, you can hard code, you could say don't create this until this is created, or if you do something like a lookup, it will automatically create it for you in the graph. Right? So this will actually pull down a Docker container, and when the Docker container is finally loaded, like pulled down, it will automatically launch it. So the syntax is very similar, as simple. Yeah, maybe I'll show you a couple examples here. Let's see. So the first thing I showed you there's, if you look, we have a ton of samples in Converge and Git repo. And I'm going to see how I can do this. I'm going to try typing and see how this works. How many folks have used Go before? Okay. So the first thing we do to get Converge is you could just do like curl get converge.sh and patch it. I know people hate this, but yes, we actually do support GoGet too. So, but this is like, so this will automatically detect if you're on a Raspberry Pi or a Mac or whatever. So that's the first thing, installing it. Now another thing is it's just a single binary. So we could do things like validate all our files, right? So I'm in the samples directory, and you could just basically say, hey, are there any syntax errors in any of our files? If you've ever used Go, we reformat the files too. So there's only a single way of writing Converge files. It's kind of like Go. And if you mess up the syntax or put spaces or anything like that, like if I, like let's say I put spaces in here. We do converge format, wait ACL. They'll come back and format it for you, right? So we're very much about correctness because we talked about CI systems, right? So we want to make sure that what we're checking in is actually complete, concise, and no arguing about formatting. So, and I should add that Converge is completely written in Go, right? So that's the first thing. So then I'll just show you a really sample of what it looks like. So we'll do file content, right? So if we do Converge plan, and I'm going to do local here because we're not talking to the RPC port. Right? So this is the first thing, and I'll show you what Converge looks like when I run. So you see up there, you see gRPC and REST. We'll talk about this in a little bit, but we're actually using Google's protocol buffers. But really, here's the main thing here, right? Like Converge will look at all the things you asked for, and it'll calculate a delta for you, right? So this is just a plan, and it'll come back and say all the things you want to do, right? So we just create it when we apply it, and when we run it again, it comes back with 0 changes, right? So this is something else because this is not added yet, but a big thing we're talking about is doing compliance management, right? We actually want to examine systems and see if anything's gone out of compliance. So this would be in terms of, for the US government, there's DISA standards, which are called STIGs, which are basically a set of standards how systems are configured. So we're really starting to think about what's the life cycle like, and I'll talk about that in a few minutes, but basically the new life cycle for DevOps that's going to emerge. So let's go back to the talk. We also have autocomplete, bash autocomplete, so you can do things. I'll not demo it here, but it's pretty easy to generate. And generate your man pages. Well, let's get some examples. There's a couple things I want to show here. One of the things we found that was a big problem with Ansible was modularity, that it was really hard to compose systems and share code, right? Like, people end up putting everything in a big repo, right? Or they use Git submodules or something like that. It's kind of very messy. So there are a couple things here. We have this idea of a module, you see up there, and then we could override the parameters for it, right? So what you could do is, modules could actually be loaded off the web like static files, right? So you could put all your modules like in S3 on Amazon and just override the parameters when you run it. And so we don't want to have force people to have a centralized server. We want to have really simple configurations. Again, we want to make it easy, so we say put some static files up there, so then your company could have basic things on your S3 share, and then you can override it on the command line, right? So, and make it composable too, right? When we have these separate modules, it makes it easy for groups to create their own modules and share them. So that's one of the cool things here. So you see this params here, so we pull in the module, and then we override the parameters because we're running Docker, right? So you could either do this on the command line, or you could run it here, and you can see all the things you can set in the Docker container. And then finally, you see this file directories data. So for the graph engine, we're creating a specific here. So this will not execute until that directory is done, right? So we're making it very easy to create this graph for you. Another example is we have this conditional task execution. So this is kind of, we're kind of really pushing HCL with this, but we actually, so this is kind of a good example of a couple things that Converge can do. So basically, this is for platform detection, right? So in the first case, if it's one of the Red Hat variants, it just uses the RPM package to install things. The second one is we left this. There is an app package support, but we wanted to demonstrate something here. You see this check and apply? Basically, any task that could be run in the shell can be wrapped into the Converge graph, right? So the check, if this exits with a non-zero code, it means that the apply has to be run, right? And then we could override the environment variables, the execution directory, and the interpreter, right? So you can run a Ruby script, and if the Ruby script comes back with a 1 error, it'll actually be the apply. So you can take your own workloads and put them into a graph very easily. Another really cool thing we have is we have this idea of wait query. So you could run things and say, hey, don't do anything until this executes and time out after 120 seconds. We're doing certain kinds of workflows, the way that things are available. And here's more of an example. So you could just take a task again, and you could just take here, like your shell script, this is just raw shell code. So it's looking if this file exists, it'll unzip it, and they'll do some other things. So it says run this in bash. And again, you see the dependency. So it's very easy to take your existing code and put it into this kind of graph. But what we're finding is the way we're developing Converge is when this gets kind of annoying to do, we write a new resource, right? So we have logical volumes, packages, systemd. We're constantly adding new resources that are built into Converge. We already have this knowledge, but if it's not, we just wrap it in this. So I really want to talk about the DevOps lifecycle, because our experience with Mantl made us think a lot about the way DevOps is going in the future, right? We're moving to a platform. If you see things like Docker Machine or Kubernetes Kops, things are getting a lot easier to install. Used to be complex deployments like Raft, Docker will take care of it for you. So an important part of that, though, is that we're seeing is that a lot of people are starting to move to, I'm going to bake my Docker containers, or I'm going to bake an Amazon image and then just launch it, right? That's their CI system and not touch it. So really, Converge is actually built into Packer now. So you can actually just create VMs on almost anything using Converge. So you can build your images. You can just, since it's a Go binary, you can pack it inside Docker and do the same thing. There's a Vagrant plugin and there's a Terraform plugin, right? So then you can use it for deployment, and from Cloud Init, you can just call it. And then finally, as we get to the directory, we're going to use Raft-based backends for when we start doing cluster management. And that's basically so we can do things like watches and locks and canary deployments. So what we're really thinking about is the more we talk to DevOps people about where they're going, they're really going to move into this where they're building immutable images, right? Like they're going to build an image and then launch it in an Amazon scaling group, and they'll do some configuration after the fact. And for the validation, what we're seeing is that there's a lot of things like PCI compliance and government compliance that needs to be done. So this is kind of a big gap right now. There's like third-party tools for things like SaltStack, but a lot of the tools don't really have a good validation story to them in terms of what might be good for an audit context. So finally, well not finally, but really one of the biggest drives for this was Mantl, right? We didn't want to have people run Terraform and then run Ansible, right? We want to have people say, bring up a whole cluster in one shot, right? And we're moving a little bit away from Mesos. We're moving more towards things like Kubernetes, Swarm, and Consul. So this was kind of a really big goal for us. Like we wanted to have the experience that each run one command to bring it up. So I'm going to show the Terraform integration here. It'll take a couple minutes, so let's see how this goes. If the network's been iffy today. So I'm going to go into the examples, and there's a couple things here you could do. There's Kubernetes, there's Docker. We're going to do Docker Swarm since that tends to move the fastest, right? If you've never seen Terraform before, it's actually going to spin up an entire cloud for us, right? So it's going to create an Amazon S3 bucket for us. It's going to create a VPC. It's going to create all the networks and everything, right, in one shot. This is what we really like about Terraform. At the end here, you're going to see provision or converge, right? So once we bring the systems up, we're actually going to pass in Terraform variables into converge, and we're going to call it, right? So this is it. So we're going to see if this works. Make sure I have some credentials here. Okay. We'll have to clear that out. Well, it'll be on the video, so we'll have to regenerate it. So we're going to apply this. This will take, depending, it should only take about 3 minutes, but the Wi-Fi's been iffy, so we'll let this start and let's see if it goes. What Terraform is going to do is it works on an API basis. If you haven't used it before, we recommend a lot of folks do it. So we'll see. Okay, so now you see it's creating IAM roles. It's going to start creating the nodes and doing everything else. So this will take a few minutes. Let's let it kick off and see if it actually starts going. Right, so as I said before, it takes a few minutes to get everything configured. But you can see here we're doing things like volume size and type, right? Like with Terraform we could create things. So now it's starting to create the images. So it basically created the VPC, the security groups, the networks, the subnets, and everything, and then it's going to add the things later on. So that's what it's doing right now. So let that go. And so let's talk about dependencies. I've kind of talked about graphs in the abstract, but I want to talk about what does it actually look like when you use a graph on infrastructure. So this is actually something that we're doing right now, right? So if you saw the manager talk, it's a little bit. So what we're going to do here is we have a Docker module. You see up there? and we're going to install Docker. So the first thing we do is we set up a Docker Yum repo, then we install the Docker packages, we create the Docker user group, we enable Docker in systemd, and then we start Docker, right? So this is basically how we visualize it. And then you see there's another module here that goes AWS CLI because we're using some things. So it's actually very easy to create these graphs and have dependencies and things like that. So that's happening behind the scenes right now. Right. So basically all you have to do is just do converge graph and it'll spit out a dot file for you. See how our little install is going. Yep, it's still going. So what happened now, we brought up the 3 systems and now Converge has been activated. So what it's basically doing is configuring each of the 3 nodes, and then it's going to take some of the shared information state that Terraform has about the S3 bucket, the IPs of the systems and things like that, and it's going to pass it in so the swarm can then join itself in a cluster. So it's going to take, I think just from before, it's taken a few minutes on the Wi-Fi, so. Let's see. So we'll let that go. And again, the weight dependency, we showed that before, right? So actually, it's going to wait till Docker Swarm is up. So it's waiting for a port to be open, and then what it's going to do is it's going to go talk to the S3 bucket that has a shared token that the systems are sharing, and then it's going to start Swarm and join it, right? So again.
Is the weight dependency actually waiting on an event, or is it just polling until something happens?
It's polling. Yeah, it's, which I thought was really interesting about management, like, and GMT, sorry. Yeah, we have our wait basically will query every few seconds, right? So when you do a wait query, it basically waits for a certain condition to exist. And I guess that could be different on different systems, but right now we're doing a polling. Let's see if our Docker is up. Yeah, it's still installing Docker, so let's see how it goes.
You run in parallel?
Yes, the graph is, so our graph is basically written by a couple of Haskell people, so the first run of it was kind of Haskell and Go. We actually have a Go library called Go FPER, because it's like Gopher. We've rewritten it, but we have this lazily, the graph engine is actually very sophisticated. It's had a lot of engineering work. It's a lazily evaluated graph engine that can run things in parallel. It's pretty slick, and we've done like a lot of things about like what happens in the difference when you're planning versus applying, because when you're planning, you don't know what the output of the other tasks are, right? So you kind of have to simulate what's going to happen down the graph. And again, it runs in parallel, and it almost runs in 2 parallel. There are certain things that can't handle being run in parallel, like apt. So we've been adding more things like auto grouping. And a really important point for us is pinpointing failures. As I said before with our Ansible example, if task 135 failed, we want to pinpoint it pretty fast, right? So we want to say this is the point in your whole graph execution that the error is at, right? A big thing for us is how do we eliminate errors before they happen? And another part of that, when you saw some of our HCL, is starting to think about core primitives as types, right? So if you know anything about programming, like having a good type system. So this is not totally in the system yet, but things like an IP address will be a type, right? So it can only have certain types of values and then you could act on it, right? So we're kind of thinking about how do we eliminate failures, because we've had too many cases where like a variable wasn't set in Ansible and our entire cluster didn't come up, right? So we want to be able to say, hey, that's not a problem, that it has to be non-zero. As I said, it's good having functional programmers on your system because they really think about these things. So here, the cluster's up. We have an IP back. So let's log into that and see what's up. Yeah, so that's basically it. So we brought up a 3-node cluster. We created a key that was shared in an S3 bucket, and then we just brought it up. So this is kind of what we want to do. This is what we wanted to do with Mantl from the start, like a single command that we can embed, that we could pass in IPs and like storage information to the nodes themselves, and then run it like that. So that's kind of one of our big goals.
Terraform kick off your
Yeah.
Converge run?
Yes, it's a parameter within Terraform.
Okay.
So yeah, Terraform, the same way we have it with Packer, right? Like Packer will just, once it brings up the image, it'll automatically call Converge, and then Converge will configure the VM. Because what we're seeing a lot of people saying, a lot of folks just want to build their VMs. They don't want to use Chef or Puppet, and then they just want to pass some things and maybe a cloud native. That's becoming a very common pattern right now. Speaking of unattended installs on scaling groups, IoT devices, can we pull so a big thing for us is pulling files from HTTP, right? Like we want to throw something out in the field, but a big problem with that is security. So we actually have PGP support for modules. What this means is that you could put your files like on an S3 file, you could sign them with PGP, and then it won't run unless it's signed, right? So you could take like a Raspberry Pi device, you could ship it out in the field and say, configure yourself from these files that are on S3, but it won't configure itself until the files are signed by PGP. So this is an optional thing that you can add that you could do signing. So we're starting to think about like within organizations, how do you distribute software and configurations so we could have sign. Now the first thing is PGP, which is kind of a pain. We were thinking about other things that we could use for verification, including a couple folks have talked to us about like using blockchain for like different groups like verifying their info, but so far that seems very complicated. So the number of people who would like use the Venn diagram of people who are running blockchain versus who are interested in like next generation infrastructure is probably pretty small right now, but we've been talking to folks about it, especially on the device side, right? Like how do you verify devices out in the field and how do you manage them after the fact? You know, a lot of times what's happening when we talk to customers is they have a device, like they ship it out to a customer, right? And you know, they boot it up and then the device has to configure itself and then you have to talk to it after the fact and manage it centrally. This is a very common workflow, so we've been thinking about that a lot as a use case. See, I'm running time. So, 27 minutes. So, we're also focusing on developers a lot because in our talks, the four big tools, Chef, Ansible, Puppet, Salt, have not really gotten any traction outside of DevOps people. And I know I'm at a DevOps conference right now, but developers don't tend to use it. Nobody else in the organization uses it usually except one or two people. So we're like, how can we have developers use these tools? So we've been really thinking about how can we make it very simple, right? So that's why a lot of our tasks are there. We're thinking for a lot of repos, you could just have an HCL file that basically allows the developer to configure their desktops in a certain way, or a Docker container, and then you just throw it up on HTTP, right? So I kind of showed some of that. And finally, communication, right? Like, so there's a lot of different ways that communication happens between, with Ansible, it uses SSH, which we found was okay to start with, but for ongoing maintenance, it wasn't great, because then you were dealing with having to have SSH keys on the centralized system. So we're using gRPC, and how many folks here have heard about gRPC? All right, Prometheus guy. So this kind of says where it's coming from, etcd, Kubernetes. gRPC is protocol buffers over HTTP2, right? So this is really emerging as the new standard for communication among microservices. So we kind of jumped up. gRPC just turned 1.0, I think, in the fall. So it was one of our first decisions was we want to have a standardized way of communicating with the nodes. And one important thing about that, everything we do, like one problem we found with existing tools is like remote versus local is different, right? Like on a lot of these tools, we just wanted the exact same experience. The only thing is you just change the endpoint that you're talking to, right? So when you run Converge locally, it kicks off an RPC server internally, but you could just say, point that exact same job at a remote system and it'll look exactly the same. So that's very important to us. We want everything going via RPC. We want to expose the devices. You can optionally run the devices in server mode, which means they just expose a REST and gRPC endpoint. So if you have any other tooling, they can just talk to the device and configure it. And obviously, this is coming in our UI, but it supports bi-directional streaming. So this means that we can actually get live updates from the system as the graph gets computed for our UIs, right? So we'll be able to see as you walk down a graph and do all the tasks, we'll be getting live updates of what's happening on the way back. So we're pretty excited about that. So that's pretty much, I think, I could go through some more examples, but that's kind of a summary. Like, really the first thing we're really thinking about is development pipelines. Like, as I said before, just based on our experience of deploying lots of Kubernetes, Consul, and Mesos clusters, really thinking about how can we make that experience better. Lifecycle, like the new lifecycle is emerging, right? That where you build immutable images and you deploy them and then you get rid of them when you're not needed anymore. And tools like Swarm and Kubernetes can take care of rescheduling jobs when those nodes disappear. And finally, there's a big gap between compliance and ops. SecOps is a very young industry right now, but like how do you actually verify your configurations that they're proper and correct? And they haven't drifted. It's almost two complete different industries right now. So we've been thinking a lot about that too. So those are kind of how we see the future coming. So that's kind of what Converge is. So just want to thank everybody. It's at converge.aster.is. We have a Slack. We're on GitHub. It's an Apache 2 license that's written in Go. So it's pretty open. I think we've had 17 contributors so far. And I think that's mostly what I have.